In the sum of an arithmetic series video, I was able to sort of build the summation formula for you. There is no way I'm going to be able to convince you that this is true without a truly heinous amount of algebra. So we're just going to take a formula and we're going to test to make sure it works. So I'm going to come up with a geometric series. So let's start with 7, and then we're going to double it each time. So 7 multiplied by 2 would be 14. Double it would be 28. Double it would be 56. And I'm just going to stop there because that should be enough to make sure this works. That's term 4 in this series. So my n value is 4. The r value is 2 because I'm doubling each time. And the a value would be 7 because that was my first term. Now if I add these up manually, which I can do with 4 terms, I couldn't do it with 400 terms, but I could do it with 4. 7 and 14 is 21. 21 and 28 is 49. And 49 and 56 is 105. So these 4 terms add up to 105. So if this formula is correct, cross your fingers, it should spit out 105 if I make n 4, a 7, and r 2. So I'm going to try that over here. The sum of the first 4 terms should be 7, because that's my a value, 1 minus 2, because that's my r value, to the 4, because that's my n, divided by 1 minus 2. Okay, so some bedness to do here. 2 to the exponent 4 is 16. And 1 minus 2 is negative 1. 1 subtract 16 is negative 15. And 7 times 15 divided by negative 1 gives me 105, which is very exciting. Because it means that if I have a sequence like that, and I want to add them all up, which makes it a series then, not a sequence, I don't have to do it, I don't have to generate each term and add them manually. I do have a formula that works for presumably any value of n, any value of r, any value of a. So if I wanted to continue the sequence, right, find the sum of the first 20 terms. Well, the sum of 20 would be, it's still a, that's 7. It's still doubling. Now I have 20 terms instead of only 4. Divided by 1 minus r. So I need 2 to the exponent 20. Gives me 104,857,6 over negative 1, which is 7 times negative 104,857,5 over negative 1, giving me a grand total of 7,340,025. So if you were to set up a sequence like this, a series like this, starting with a 7 and then doubling each time, if you added up the first 20 terms of it, you're already up to 7.5 million. So that's real fast. what could possibly grow that fast? Well, if you have bacteria in your body, and you start with some of them, and then they double every so often, after only 20 divisions, you're up to 7 million bacteria. So if you don't have an immune system hacking away at them, this is problematic. Unrelated to raging infections, but also equally stressful, if you are making car payments, you make a payment, and then you make another payment, and you make another payment, but each one, the value of the loan you're paying off is increasing because the interest you owe each month is decreasing. That's complicated. We call that an annuity, but it's this type of calculation where you would have to take a bunch of payments, each multiplied with interest over and over and over again, and add them all up to get the total amount of the loan. It sounds complicated, and it would be particularly irritating to have to do it manually by writing out every single term and then adding them all up. But it should, take heart knowing that there is a formula out there and there is some structure that I can use to try and actually do the sums of these sequences. Series. Okay, I'm going to clean this off. That was an example of solving for Sn if you know A, R, and N. So I'm going to try one where we solve for A. Okay, I've got another example here. The sum of a geometric series with an R value of 3 is 4,782,966. First term is 6. How many terms are there? Okay, so that's a bit abstract. But this question is sort of the structural equivalent to saying you want to buy a $4.8 million home. The interest is 300%. You're making $6 payments. How many payments you're going to have to make? So that's not right, and the answer is not going to sort of match that example. But the idea is that you have some amount that you're trying to build up to, so you know that ahead of time, the price of the house. You know how the interest rate is affecting this, and you're trying to figure out how long you'd have to wait at that sort of payments plan. Okay, so I've got a question here, or a formula. Some number of terms, I don't know what it is, it's going to give me 4,782,966. Making $6 payments for however long this takes at an R value of 300% for some number of terms. Okay, so I have some apparently I've been sitting still for too long. I have some algebra I can do here. First off, I can do 1 subtract 3. That gives me 2. And I can do 6 divided by 2 to give me 3. But I cannot combine these two terms. This one does not have an exponent, this one does. So from here, I have to flip into algebra, trying to peel numbers away. So I'm going to have to divide both sides by 3. Right. Divide by 3 will save me some pen strokes. So 4782966 divided by 3 gives me 1595. 4, 3, 2, 2. Oh, sorry, that's negative 2. Gives me negative 3, and that makes this negative that. Subtract 1 from both sides to get rid of this thing. Should give me negative 1, 5, 9, 4, 3, 2, 3. If negative 3 to the n is negative this number, then positive this number is positive 3 to the n. And I have a variable up and an exponent, and the way you break that is by introducing logarithms. So I'm going to need the log of 159, 4, 3, 2, 3 is the log of 3 to the n. So log 1594323 over log 3 should give me my n value. Try that. Log of 1594323 divided by log of 3 gives me 13 on the nose. Now that's encouraging because n is a counter, right? N belongs to the integers because you can't have half a term, right? You have to have a full term in your series. So this has to be a nice round number if the question is prepared correctly. So how many terms are there? There has to be 13 terms in this particular series in order for them to add up to that quickly. Now, back to the context of the money question. While I was thinking about this, this is a build-up question rather than like a mortgage. So this thing, in terms of finance, is saying you're making monthly payments or yearly payments of $6, but the interest rate is 300%. So what would happen if you made $6 payments with an interest rate of 300% for 13 years? Well, you'd end up with $4.5 million. 300% interest, that would be wild. We'd all be billionaires if that's how the world worked. Okay, so I'm going to clear this off. We need one more example where we solve for A, and then we are good to go. The last example here, each term of a geometric series is half the size of the one that came before it. The sum of the first 12 terms is 16,388. What was the first term? So I have sum of the first 12 terms. That's 16,388. I don't know A, but I know that R is 0.5 because each term is half of the one that came before it. And I'm going to do that 12 times. All right, so I got all my numbers filled in there. So 16388 is my A value. 0.5 to the exponent 12 gives me 0.0002444140625. 1 minus 0.5 is 0.5. So 1 minus that number, 1 minus my answer, gives me 0.9997558,594. We'll do this divided by 0.5. gives me 1.999511719. And to finish, I just need to do this divided by this. And I get 8,196.000977. Okay, now, somewhere along the lines here, I've had to do some rounding, which means that when I calculated this, I get this little tag here. So I'm going to guess that that answer should be 8,196. And if you're not sure, you can take that, park it in here, and then try and work it out to test your theory. So would the sum of the first 12 terms be 16,388 if the A value was 8196? So 16, well, that's my target. So 8196, 0.5 to the exponent 12 I already have, is 0.000244140625. 1 divided by 0.5 is 0.5. 196 multiplied by 1 minus 0.5 to the exponent 12 gives me a syntax error, which is annoying. 1 minus 0.5 to the exponent 12 divided by 0.5 gives me 16,388. Okay, so it worked. All right, so if you know the sum and you know the rate and you know how many terms there are, then you can just use algebra to solve for the first term. Now, I do want to clean this off here and then talk about solving for R. So I'm going to take this equation here and just to get rid of some of the letters, I'm going to let Sn equal 10. I'm going to let A equal 2. And I'm going to let N, well, I'm just going to let N be N. So if I fill that in here, I'd end up with 10 equals 2, 1 minus R to the N over 1 minus R. Now, if I'm solving for R, I can't have it in the denominator. So I'm going to multiply both sides by 1 minus R. That will eliminate it on this side and give me 10, 1 minus R over here. Ten times 1 is 10. 10 times negative R is negative 10R. 2 times 1 is 2. 2 times negative Rn is 2R to the N. I'm going to bring all the terms over, so I have all the like terms together. I got 0 equals 2, subtract 2Rn, subtract 10 plus 10Rs, which gives me negative 2R to the N plus 10R minus 8. Okay, we're going to look at that particular thing here. If N was 2, you're only allowed 2 terms in this sequence, that would make this a parabola. And you could use quadratic formula in order to solve this equation. If N is 1, you would have something linear, so you could solve it. if n was 0, this term would drop out and I could solve for r. But for any numbers other than n is 0, 1, or 2, you don't have algebra skills in order to solve this. This can only be solved if n is greater than 2. You need a thing called Newton's method. Let me write that down to solve this. And that's a calculus technique. So in a few courses from now, you would have the skills you needed in order to actually solve this equation for some number of terms larger than 2. But for now, in grade 11, this is beyond you. And since a sequence with only 2 terms in it is not really worth dumping into a formula like this, you might as well just do it manually. We're going to just sort of avoid this kind of question, which is unfortunate, because in a finance sort of mindset, the thing that you're actually looking for is R when you're shopping around at banks, right? If I know I need to buy a $500,000 house, that's this. And I know I can make $1,000 a month payment, that's this. And I need to get it done in 40 years because that's what the government mandates, right? Like mortgages they can't be longer than 40-year terms, or whatever the legislation says today when you're watching this video, but there are limits on how long a bank can extend your mortgage. So you'd know N, you'd know your payment you can make, and you know how much the house is to buy, but the thing you're shopping around for is interest rates, right? What interest rate will I need in order to make this payment cover that mortgage in this amount of time? So unfortunately, you'll need calculus to solve that kind of question. Don't worry, you'll get there. Okay, so we have solved for all 4 variables. Well, 3 plus the one we can't solve for in this particular equation. So I think you're good for the practice problem.